Good morning, and thank you for attending our webinar this morning. I know for some of you out west, it's a little early. We really appreciate your time this morning. I'm Alvin Jones. I'm the Director of Global Sales for Metalforms Heat Transfer. And today I will be presenting with my colleague, Shelly Rudra, who's our Global Sales Engineering Leader. Shelly and I work very closely together to close projects with our customers. My role in that is all of the commercial stuff related to terms and conditions, where we're going to go to lunch, when we're going to play golf, that kind of thing. And Shelly's team is responsible for getting the quote out on time and making sure we close the transaction. So we work very closely together. A little bit about my background. Before Metalforms, I was 15 years at Coke Heat Transfer. I had a lot of different roles at Coke Heat Transfer. I left Coke and went to work for a shell and tube fabricator in Houston for about a year. And then I heard about this Metalforms acquisition of the Coke Heat Transfer assets. And I was so excited about that because I knew a little bit about Metalforms and I knew a lot about Coke Heat Transfer. And I felt like that company, with their experience, their background, and these new products that they were bringing on from Coke Heat Transfer would be a strong company in our market. And so at the time, they were putting together their team. And I knew a lot of that team because there's people I had worked with at Coke Heat Transfer. And I'm just elated to be here working with Metalforms Heat Transfer, building out our global. Now, for this case study, we're going to need to turn back the clock to about the 2020 timeframe. At the time, I was working for Coke Heat Transfer as a regional sales manager. I had several regions, but one of my regions was the U.S. Gulf Coast. One of my customers was a refinery in Alabama. And that refinery had recently been sold, and the new owner had decided to convert that refinery to renewable diesel. I was there meeting with some of the engineers at the refinery, and they were telling me about the stress and strain that this renewable diesel conversion was putting on some of their equipment, on their fire heaters, on their heat exchangers. And they had come up with a fix. They had hired an engineering company to replace some existing shell and tube heat exchangers with larger shell and tube heat exchangers. Well, if you know anything about twisted tube, you know that that is the sweet spot for twisted tube. Anytime we hear that a customer is looking to replace existing shell and tube exchangers with larger ones, we want to be at that table. We want to talk to them about a revamp option. And so I came back to Houston, met with our team. I was so excited. I was like, hey, here's all we have to do. We just have to convince this refinery and this EPC that the path they're on is the wrong path. And we need to get them on a path that's about a revamp solution. And the team kind of looked at me as they did usually, like, Alvin, really? Well, I can tell you that in February of 2022, we received a purchase order to actually convert those exchangers. It turns out the existing exchangers they were looking to replace was one that we had provided earlier at Coke Heat Transfer from our facility in Italy. And so we were able to convince them that instead of going down the road of changing out those exchangers and all the piping modifications, all the foundation changes, the impact on their turnaround associated with that, we were able to show them that a revamp solution was a better solution for them. Next slide. Now, I've been working with refineries for a long time. In fact, my first job out of college was working for Chevron, and that was a long time ago. And the one thing that I've learned in working with refineries over the years is that they are constantly changing. The only thing that's constant is change. And whether it's something like what this refinery was looking at as far as changing their product slate, We also runs into situations where refineries are looking to change their crude slate. For example, maybe to process a more viscous fluid, more viscous crude, like a Venezuelan crude, maybe, for example. And a lot of those projects put strains on the existing equipment. A lot of these refineries were built in the 50s, and the equipment was perfect and probably oversized for what they were trying to do at the time. But over time, a lot of changes, and some of those changes put a huge strain on the existing equipment. The go-to solution for customers is a shell and tube fix, like was the case here with this customer in Alabama. They look to replace the existing exchangers with larger shell and tube exchangers. And sometimes that is the best option for the customer. We know a little bit about shell and tube heat exchangers because we sell those. And so, what we want to do is look for what is the right solution for the customer. If that's an existing shell and tube heat exchanger, we have it. I know a guy in Beaumont that would love to quote a conventional shell and tube to our customers. And in some cases, that might be the best solution. But in other cases, like was the case here, there's a compelling solution that's around a revamp solution where we reuse the existing shells, we reuse the existing channels, we put in new bundles, and we will be going through the details of how we do that today. Now, as far as our agenda, we're going to talk about just a few things. We're talking about the customer's strategic decision to convert to renewable diesel. It doesn't have to be renewable diesel. Renewable diesel just happened to be a hot thing that was going on in about 2020. We're looking at some projects now where we convert to renewable jet fuel, renewable aviation fuel. Like I said, it could be a project around revamping a crude preheat train. In this case, we're going to talk about renewable diesel because that was the issue facing the customer at the time. And we were talking about why that decision created some stresses and strains on their existing heat transfer equipment. And we recognize that the solution that customer, kind of that base solution customer always going to come to is a shell and tube, conventional shell and tube solution. And shell and tube heat exchangers are kind of the workhorse of our industry. A lot of times, as I said, they might be the best fit. But we'll talk about situations where an engineered approach, in this case, would be a retrofit and why that made a lot of sense for the customer in this case. Shally will talk about some of our measured performance and maintenance results. And we really want to kind of get to a practical framework that you can look at in your refinery, in your facility, and where you may be making a change that puts a strain on your equipment, and you might want to evaluate in parallel with a shell and tube solution, a revamp solution, because there are cases where that will be a compelling a solution for you. So with that, I'll turn it to Shally.
Good morning, everyone. Again, thanks for joining us this morning for this webinar. As always, Alvin mentioned when he brought this to the sales team, we said, like, really, Alvin? But it was a good project to work on. The initial assessment was the customer planned to change the application of the existing heat exchangers from VGO to renewable diesel. The challenge was a large throughput that was going to be put through the shell side of these exchangers. Initial assessment was if they were going to keep the existing exchangers, they would only be able to meet 86% of the new duty requirements. And again, the main reason behind that, higher throughput, and due to the service itself, the design was prone to higher fouling factors. Next slide, please. From the customer's perspective, their objectives were clear. They want to change the application of the heat exchanger to the renewable diesel, meeting the new duty requirements. But keeping in consideration the best objective would be to not make any piping or foundation changes. Another key consideration was they had a critical window during which they were needing these exchangers on site or turnaround window, and thereby minimizing that operational risk. They, as Alvin mentioned, their initial approach was going through an EPC. They had the first solution from the EPC was to replace two smaller existing heat exchangers with three larger ones. The challenge with that approach, the first was the longer lead times. Again, that kind of leads itself to the operational risks, not being able to meet the turnaround window. Secondly, piping and foundation changes. So in other words, higher cost and increased risk, mainly from not meeting that timeline. When we came in, our solution was a bundle retrofit or revamp solution, putting twisted tube bundles inside the existing shells. This table is, there's a lot of information on this table, but essentially the duty requirement, or I would say in the feed temperature requirement was 702 degrees Fahrenheit, and the existing configuration would not have been able to meet that. We were able to meet that duty, keep within the same pressure drop, and by installing, a larger surface area inside the existing shells. Ultimately, given the time crunch, cost considerations, the customer, we were able to convince with Alvin's help for the customer to go with this retrofit type strategy, which it allowed them to meet the thermal hydraulic requirements. They were able to keep their existing shells because they were already in good condition. The work was limited to just replacing bundles, and the customer was able to avoid any piping or structural or foundational modifications. In their terms, it would have been a plug-and-play solution, and that's why it was favored. Again, key considerations why this solution worked, because a twisted tube technology, essentially, it works on the three parameters that affect the duty of a heat exchanger. The first one being U value or heat transfer coefficient, the second one being surface area, and the third one being the log mean temperature difference or the driving force for heat transfer. The shape of the tube itself after it's twisted leads to the elimination of traditional segmental baffles, and the tubes are placed on a triangular pitch, and then due to the shape of the tube, we're able to fit a large number of tubes within the same shell because the tubes are placed on a pitch that is tighter than TMO. So that's how it works on the A or the area. Due to the shape of the tube itself, it introduces turbulence in the tube side fluid, thereby affecting the U value or the heat transfer coefficient. And finally, in terms of the delta T or the LMTD, in this particular situation and in several others, we have a possibility with our Froud technology to be able to convert an existing E shell to an F without making any modifications on the outside, so the nozzle staying in the same location. So in this particular case study, we actually impacted all the three parameters, and that led to the success or the solution. Alvin, you can talk about the installation.
Okay, yeah, for the installation was very straightforward. All of these exchangers have removable bundles because they're in the fouling service. Customer has to be able to pull those exchangers from time to time and clean them. And what our offer was about was, instead of pulling those exchangers to clean them, you pull them and you replace them with this more efficient twisted tube bundle, saving the customer in terms of piping modifications, in terms of foundation changes, and avoiding them having to re-rate a fire heater in order to get to that. Probably the most important, and was extremely important in this case, was the downtime. These were high pressure exchangers with very complicated channels. And the channels I think were over a year to get new channels. So we were able to reuse the existing shell, reuse the existing channels, put in a new bundle when they would normally, during the time when they would normally do a turnaround, avoiding a lot of downtime and allowing them to get back up and start producing and making money again. Next slide.
In terms of the performance results, we stayed in touch with the customer. I think we wanted to get some validation on what we proposed versus what was observed. The results were very encouraging. I think the customer did confirm they got the additional duty that our solution proposed. And again, it was by adding about 35% more area. For this application particularly, the increased duty translated to about 54 degrees Fahrenheit higher feed outlet temperature, which was really valuable to the customer. Again, that additional surface area would also mean, longer times between cleanings, and that itself would be a cost savings. Most importantly for them, I think the customer was very happy with the solution because it met all the requirements, checked all the boxes that they initially came to us with.
So from a business standpoint, the impact was substantial. They were able to avoid a costly heater upgrade. We were able to reduce the turnaround schedule risk. In this case, we were able to meet a schedule that replacing those exchangers could not meet. And then in terms of an energy efficiency, we were able to improve that and improve the performance of the facility. So why is a retrofit right for you? Yeah. So process changes can involve new equipment, but they don't always have to involve new equipment. Sometimes we can revamp the existing equipment and meet that requirement that a new equipment would meet. A bundle retrofit can offer some pretty substantial value, not just in the equipment itself, but in all of those costs that are around that turnaround that have to do with foundation repairs, have to do with piping modifications, has to do with extended turnaround time. So in terms of the twisted tube, has an impact both on CapEx and OpEx and results in energy savings to the customer. So I think some of the questions for our customers is, is the exchanger, as you're making these changes in your process, is that exchanger still structurally and mechanically sound for your current process flow? Are you experiencing any shifts in your feedstock, fuels, operating conditions, maybe even, if you're like your creep slate, that kind of thing? Our capital constraints are tight turnaround, limiting your options. And if any of those questions are yes, then we ask you to just consider a twisted tube revamp solution. We realize that our customers are always their go-to is gonna be around conventional shell and tube heat exchangers. And we encourage our customers to continue to evaluate their process based on conventional shell and tubes. But in parallel with that, let us help you look at a revamp solution, because in some cases that revamp solution can be compelling when compared to changing out equipment. The next steps, we just ask you, if you don't mind, download this case study. It's been recorded. You'll be able to download it and review it later. Request a technical review. We'd love to have a one-on-one discussion with our engineering team to get more in detail on what we did here. And if you've got an application where you think it may be a fit for our technology, we'd love to sit down with you and work through the issues associated with that. Our team would be more than happy to, schedule some time looking at your specific service to see if this is a good fit. And like I said, if it's not a good fit for a revamp solution, I'll hook you up with our guy in Beaumont. You'll be glad to quote conventional shell and tubes to meet your project. I think that's it. Are there any questions? We'd be glad to answer some questions. Sally would be glad to answer some questions.
Thank you, Alvin.
Best thing. Any questions in the chat? No. Hey, please. So there's a question about weight.
So I can take the question about the weight. Again, I think as it's expected, we're adding more surface area, thereby adding more tubes and thereby adding more weight to the bundle itself. Typically, what I would see is between 10 to 15%, the weight of the exchanger would increase by 10 to 15% from existing. It could be more in certain cases. Typically, example would be a no tube and window design, and most of the bundle was already empty, and we filled it up with a lot more tubes that it started off with. In that case, the weight change could be significant. It could be 30% or more, but that's probably the limit.
And I'll take the question about the materials of construction. Of course, we can do these we do a lot of these in carbon steel, stainless steel, but we also do in very special metallurgy. We've done these in titanium. We do them in 2.25 chrome with weld overlays. I think that just about any requirement where you can meet that requirement with a conventional shell and tube, you should be able to meet that requirement with twisted tube. And if it's something we haven't done before, a lot of time, I know we've done burst tests, we've done tests on our equipment just to make sure that it is, meets the requirements. If it's something we haven't twisted before or something we haven't done before. But as a general rule, I think if there's a solution that's around a conventional shell and tube, we can provide that solution with twisted tube.
That's everybody's favorite question. Are they more expensive?
Oh, so spiritual standard expensive. Definitely more expensive. Yeah. And the reason it's more expensive is because we're going to pack a lot more. So if you look at a 32-inch diameter shell and tube, twisted tube exchanger is going to be a lot more expensive because we're packing a lot more tubes inside of that existing shell. And there are situations where, let's just say, a shell and tube option might be the most economical solution for you. When this twisted tube starts to make a lot of sense is when you start getting into things outside of just the equipment itself. It's all the advantages that a revamp or a revamp solution brings in terms of foundation repairs, in terms of a piping modification. And then also it's the extended turnaround. In this particular case, as we were saying, they couldn't meet their schedule with a conventional option because they would have to replace the shell and the channels and all of that. In other words, very long lead items. We were able to reuse all of that and provide this within their turnaround schedule. And so it's going to be more than just an evaluation of the equipment. But to answer your question, yeah, it's going to be more expensive, mainly because we're going to put a lot more material inside of those shells. I missed some questions there.
We have a question, Alvin, related to cleaning and inspection. I can talk about cleaning, and then I'm going to have somebody in the panel respond on the inspection. So in terms of cleanability, the tubes are on a triangular pitch. They are cleanable on both the shell side and the tube side. The methods of cleaning are comparable to your conventional plain tube heat exchanger. It may take the time it takes maybe a little bit longer because again there's more tubes and then you got to clean through different areas. In terms of the tube side, you would use a regular lens. The only difference would be that for a comparable plain tube OD, the lens size would be smaller because after the twisting operation, the effective round ID of the tube is going to be smaller than the bare tube.
Okay, so Mr.
I would say we work a lot, and I know Matt's going to answer here, but I was just going to point out here that we have third parties that we work with that help us a lot in terms of inspection, in terms of cleaning, in terms of coatings and stuff like that. And they're on the call, they're muted right now. And so when you get to the point where if there's a specific question about cleaning or inspection, we have Ms. Strauss on the phone on this call with us. They've done a lot as far as inspection. We have IGS, they've done a lot as far as cleaning. We have Current who's on here that has done a lot as far as coating. And if you're interested in a more detailed discussion, I'd be more than happy to, and they'd be more than happy to talk to you about their experience.
Sure. Yeah, so I'll speak a little bit on the inspection side of things, and then I know Tim is on the line, so any detailed question can definitely go to him. So from the inspection perspective, we have a couple of options available. One of the simplest one is APRIS, which is acoustic pulse reflectometry inspection method. This is a non-invasive method where a probe does not have to go inside the tubes, and the adapter, which basically inspects the tube, sits at the end of the tube. It does cover some of the defects or some of the concerns that the customer is looking for at the time of inspection, such as wall loss or having a pinhole or a pitting in the tube. So those things can be covered pretty effectively through APRIS, and having a baseline inspection done when the bundle is first assembled, that creates a good basis for later on when inspection is to be done on the tubes. The second one, which is more conventional, is the eddy current testing, which is used by a lot of our customers, and Tim has a lot of experience with that, and he can from Mistras, and he can fill in as needed. The third one, which a lot of our customers have started to use, is along with the twisted tube, we would put some round plain tubes in the different quadrants and embed them in the bundle. That way, customer has an ability to see how through the regular inspection method which are available for plain tube, just to see how would be the effect on the rest of the bundle happening, which is general corrosion or pitting or any of the concerns that they have. So as I said, there are several options available, and depending upon the situation and depending upon the concern of the customer, those could be picked up and used. One last thing, I'm going to talk about the question that was about the weight and the increase in weight. I just wanted to let the people on the call know that our engineers, when the weight goes up and customer has a concern, we do support the customers in evaluating the supports as long as we have the details available. Thank you.
And Matt, while you're there, can you talk to this question about tube side and shell side pressure drop?
That's a Shani question, sorry.
Oh, okay. Go ahead, Alec.
Yeah.
So I can take the question about the pressure drop. So typically the change in pressure drop on the tube side is negligible. So there is a loss in pressure drop due to adding more tubes to the bundle, but it's offset by the way the shape of the tube is. But I would say I've never seen that it exceeds, the pressure drop of the plain tube. In terms of shell side pressure drop, since we eliminate the segmental baffles, in the cases that we stay with an each route, the pressure drop is significantly less on the shell side. In case of an F, if there's an F conversion, it's comparable, but again, it's a comparison of what heat transfer coefficient improvement it gives versus how much the pressure drop increases. So, and a lot of cases or applications that we have seen, the customers looking for an overall pressure drop. Again, I speak specifically to, let's say, feed effluent type applications where customers looking at the combined pressure drop on shell side and tube sides. So in my experience, I have never seen that it exceeds the overall combined.
Okay, that's good. I think that covers most of the questions. We're going to put up here some contact information. If you have any other questions, there's my info, there's Charlie's info, there's our phone numbers, there's our email addresses. If you have any questions, additional questions, or any concerns or anything you want to discuss in more detail about what we covered here today, please reach out to either one of us. We'd love to have more detailed discussion with you on it. Thank you so much, and thanks for your time today.
Thank you everyone for attending. I would add to what Alvin said is also reach out with feedback. If we could have done this better, how we can have maybe more interesting content, because we plan to do more of these in the future. I think it will be helpful for us and the customers. So thank you again.
Okay.